If you're confused with trig integration, this video is for you. To start off with trig integration, we first have to learn the basic trig integration principles, which means if you have the integration of sine x, for example, it goes to negative cosine x, and the list will come up as it goes. And first thing you do is make sure you memorize all of these by heart. So you might have to do that. You may want to write them down and copy them over and just keep drilling them in your head until you get them, because it's really important. Second, if your answer begins with a C or has a C in it, for example, sine x equals negative cosine x, and anything like that has a negative sign. So if the answer begins with a C, negative sign, which will make a whole lot of difference on your test or quiz or whatever you have. In C, for example, cosecant squared x goes to negative cotangent x because it's a C answer. And when you're doing these integration problems, make sure you put the plus C after everything you do, because the whole other problem could be counted wrong if you forget it. So do not forget the C no matter what you're doing and that. So make sure you copy all these basic principles of trig integration down. So here's the first example. We have the integration of 4 times the square root of x minus secant x times tangent x dx. So first what you want to do is switch the square root sign to a 1/2. This will make integrating easier. This is just a straight up integration problem. You don't have to do direct substitution by u or anything like that. So first you just do, you raise 1/2 to the power 1, put the reciprocal on the outside of the 4, x to 3/2, and this is one of your basic trig integrations. Secant x tangent x is equal to secant x, and you just simplify. 2/3 times 4 is equal to 8/3, and that's all you have to do for this problem. Nothing else. It's as simple as that. So your answer is 8/3 times 4x to 3/2. So here's our first example with u substitution. We have sine of 3x dx. The u is 3x because we cannot solve it straight up because we just have sine x. So we have the derivative of that, which is 3 dx, which then when we simplify it to make it equal to dx, it is 1/3 du dx. So when we put it back in our integration problem, we're going to substitute dx for du, and we're going to put the 1/3 on the outside so we don't have to mess with it during integration. Then we simply integrate it. So you have your negative 1/3 times cosine x times cosine u because of the what you just integrated, and then because of your basic trig properties, and then you simplify it down again, and you substitute u for 3x, and that's all. Our second example with u substitution. First we want to rewrite it out to make sine x all squared to the 6th, not just the 6th, because it's a lot easier to see what you want to use u, because you can't just simplify sine x to the 6th. So that makes it your u, du, is cosine x, because that's the derivative of sine x. So you see how convenient it is? You have cosine x and dx. So then when we resubstitute in there, you substitute all that stuff for du, and you have u to the 6th. We integrate that to make that 1 to the 7th to be u to the 7th du, because you raise to the power and do the reciprocal, and then you just substitute u in, and bam, there's your equation.